Oh boy, it's one of these again. Here we go. So obviously I'm not going to use Weierstrass, because, I mean, I know nothing about the hyperbolic version of Weierstrass. And I want to keep it simple. So I'm going to go convert this into exponential form. So we're going to have this, and dx, and then we're going to have to turn this in multiplied top and bottom by 2, and we get this, and then we have to multiply top and bottom by e to the x, because it's just simpler, it makes life more simple. X plus 1, just like that. This is all still inside of an integral, it's just redundant. So now what we have is when we let u equal e to the x, this should just be 1 to infinity of 2 du of u squared plus 4u plus 1. Now of course, you know me, I'm going to complete the square. So we have 2u du u plus 2 square minus 3. Right? Because I'm doing plus 4 minus 4. And now this is simply negative 2 root 3 inverse tanh of u plus 2 over root 3. And there we go. From infinity to 1. Okay. So plugging in infinity, it's 0. And plugging in 1, you got to be careful because that's more than 1. So, of course, in most integration bees, you cannot leave your answer in complex form. Okay? And if your inverse tanh of some number, and that number is bigger than 1, that is a complex form and you need to change it. Okay. So infinity, plugging in infinity is going to be 0. Okay? Because we know, oh, if I write this out for you, inverse tanh is equal to a half ln of 1 plus x over 1 minus x. Okay? The best way to memorize this is that inverse tanh of 1 is undefined. Okay? Now plugging in this infinity here, taking the limit, it's going to equal to negative 1 inside. However, we have absolute values, so that becomes ln of 1 instead, and it'll just become 0. Okay? So what we have is this is just simply 2 root 3 inverse tanh of root 3. Again, we cannot leave our answer like this because most integration bees do not allow complex forms. So we're going to have to change it in ln formation. So here we have 1 plus root 3, 1 minus root 3. You see there's a negative here. And so now our answer is simply 1 over root 3. Ln of this just becomes this because of our absolute value. And then now you can go ahead and conjugate top and bottom. We get 2. You can actually take the 2 out because it's just going to be a square of root 3 plus 1. Okay, I believe they, let's see, 2 plus root 3. I think they simplified it. What they did is they squared it, root 3 plus 1. Oh, okay, no, I'm sorry. I lied. I messed up. I can't take that out. No, that's my fault. You can't take that out because this 2 here. It was originally this when you conjugate it. So, no. Okay. No, that's my fault. No. The answer here would definitely yeah. It would just be 2 plus root 3. Yeah, this is the correct answer. Yeah. Okay. Be very careful. Do not end up like me. Okay. Accuracy is very deadly here in this integral. Okay. So, yeah. Be very careful, and I hope this is helpful. All right. I'll see you guys in the next video.